So, the next 2 units, actually, we are going to deal with a very important topic in math, high school math, and it's the part of math in which we use letters and other symbols like plus, minus, division bars, okay, numbers, and we use all of this to represent formulas or equations. And what do you think we call that type of math? Algebra. Algebra is all about formulas and finding unknowns. Okay? And these unknowns that we find or we use in formulas, okay, are usually lowercase letters like X or Y, but you can use any lowercase letter you want. And do you remember what we call these things? Variables. So in this unit, we're basically going to deal with expressions, okay? Or you can think of them almost like formulas. And we're going to talk about how we use them to find values. We're going to talk about how we simplify them, okay? And then the next unit, we're going to get into equations, which is the other big part. Because there's 2 big parts to algebra that we're going to look at this year: simplifying expressions and solving equations, okay? And these expressions are usually called a polynomial. So a polynomial is an algebraic expression that contains variables, sometimes one, sometimes many, operations like plus, minus, and even exponents. But the exponents must be whole numbers. And what I mean by that, the exponents have to be 0 or 1 or 2 or 3, etc. We can't have negative exponents. We can't have fraction exponents. We're going to look at those 2 types next year. Okay? So here's an example of a polynomial. It's an algebraic expression. This one happens to contain one variable, x. It's got some operations in here, minus and plus, and even multiplication in these 2, because remember 2x is the same as 2 times x. Okay. Also has an exponent in here. And actually, I should have added numbers. Forgot to add numbers. So a polynomial has a certain number of terms. In this one, there are 3. And they are 3x squared minus 2x plus 5. We separate it like that. And how do we count the number of terms? They're separated by plus and minus signs. So both I've got 2 plus and minus signs, which means I'm going to have 3 terms. If I have 4 plus and minus signs in there, I'm going to have 5 terms. It's always one more. Okay? And what are terms? They are numbers variables and or exponents. So it could be just a number. So as an example, or as examples, 7 could be a term. It could be a variable. X could be a term. It could be those two multiplied together. 7x. That's another term. Or we may have an exponent. X to the third. Well, let's do 7x to the third. All of those are examples of terms. Okay? Now, do you have to memorize these definitions? No. It's just that when I refer to these words, you should know what I'm talking about. Okay? Like when I say exponent, you should know what I'm talking about. When I say terms, you should know what I'm talking about. Some other things that we need to know. Coefficients. Okay? Coefficients are the numbers in front of a variable and if they're in front of a variable, that means they multiply the variable. So in this example, what are the coefficients?
3 and 2.
3 and
Minus.
right. If there's a minus in front, you've got to take it as part of the coefficient. Good. So yes, 3 and negative 2. What if I gave you, so, like for example, or examples, if we said negative 5y, the coefficient would be negative 5. What if I said k? What's the coefficient of k? What number is in front of k? We just don't need to write it. Not 0, because 0 would make the whole thing disappear. 1. Whenever there is not a number in front of a variable, there actually is, we just don't write it. It's always 1. So again, you don't have to memorize a definition. You just have to be familiar when I say the word coefficient that you should know what I'm talking about. And then terms, or sorry, the term with the greatest exponent or the highest exponent determines what we call the degree of the polynomial. Don't confuse that with an angle being measured in degrees. It's not the same thing. So what's the degree of a polynomial? It's the highest exponent. That's it. So in the example above, the polynomial has degree 2. Because 2 is the highest exponent that you see. So if I gave you a polynomial like 7y to the 5th plus 3y to the third minus 10, the degree would be 5. You just look for the highest exponent. What happens though if, let's say, you didn't see an exponent? Like if I just gave you one, you don't have to write this down, that looked like this. What would be the degree of this exponent? That's the coefficient. Coefficient is -2. X is the variable. Can I write this using an exponent? X is the same as x to the 1. So technically, I could write it like that. So if you don't see an exponent, if you just see an x or a y or an a or a b or whatever, it's always degree 1. Because -2x means the same thing as -2x to the first. And finally, 5, the term 5 in the polynomial above. That doesn't have an x with it. That doesn't have a variable with it. If it doesn't have a variable with it, we call it a constant. Okay? And honestly, I want you just to cross this out. I'm not going to worry about this. You don't need to know this. So you don't have to write this down. And I thought, yeah, keep flipping the page. Okay. How many terms does this polynomial have?
4.
4. 1, 2, 3, 4. Okay, remember terms are separated by plus and minus. What are the coefficients? Somebody else. What are the numbers that you see in front of the x's? 4 is 1. What would this be? -1. And this one? 3. Okay. What's the constant? Careful. -10. Good. Okay. Finally, what's the degree? 4, because it's the highest exponent that you see. Okay. So that's what you should be familiar with. Finally, 3 more words. Polynomials. There are certain types. If a polynomial only has one term, we call it a monomial. Mono means one. So for example, if you just had the expression 2x, that's a monomial. If you had the expression -6, that's a monomial. If you had the expression -5 z cubed, that's a monomial. Thinking of these 2 letters in front, how many terms do you think a binomial has? 2. Can somebody give me an example?
-5.
That's a monomial. Remember, 2 terms has to be separated by a plus or minus sign. Yep.
2x minus
2x minus 5. Yes. Because it's got 1, 2 terms. Can somebody give me another one that has an exponent in it? Yes.
5 is 1/3 plus x.
But the exponent has to go with the variable. So you're almost there. How about 5 plus x to the, what you said? Or 2.
or 3. There's another example. Okay? Trinomial?
3.
Absolutely. Can somebody give me an example? Yeah, I'm hearing somebody start.
X.
2x.
Can you do times, or is it only plus?
Plus or minus.
Subtract 6 plus 2 cubed.
Well, I need, if I'm going to use an exponent, I need a variable. So I have to do 2xg.
Okay.
Yeah, good. There's an example. So what do we do with these polynomials? Well, when we're given one, and if we're given the values of the variable, we find the value of them. Okay? And how do we do that? We replace the variable with the number that we're given, and then we calculate. Or we substitute the numbers into the variables and calculate. And that's called substitution. You guys have been doing this for ages. Every time you find the area of a rectangle or any other shape, you've been working with polynomials. Anytime you find the surface area, anytime you find the volume, okay?
All sorts of formulas out there.
So how do we do these things? Okay,
So here's the first one, pretty straightforward. Remember what 5x means? It means 5 times x, right? So what's the value of 5x if x is 6? 5 times 6, which is? Right, so what I do is instead of the x, I'm going to replace the 6 in parentheses. And then I do the calculation of 30. And I'm done.
that's a pretty simple one. Let's get a little bit more complicated.
So every time I see an x in here, I replace it with 4 in parentheses. Every time I see a y, I replace it with -3. So be careful here because it's going to be 4 times in parentheses -3 minus, and then in parentheses -3, or sorry, my mistake. Got it. I should have replaced it with 4. Thank you.
Plus 10.
4 times 4. This changes to,
Positive.
so I got 16 plus 3 plus 10, 29.
Okay? All this next one.
So wherever I see an x, I replace it with 4. Whenever I see a y, I replace it with -3, using parentheses. So in parentheses 4, then minus. In parentheses -3, then over. In parentheses -3, then minus. In parentheses 4. And what is 4 subtract -3?
Positive.
Positive 7.
What is -3 minus 4?
-7.
And what is 7 divided -7?
-1.
Notice in this next one, I've got some parentheses in there already.
So we're going to put parentheses within parentheses. So 5, and then the big parentheses. Then I put,
Instead of X, 4 in parentheses.
plus, instead of y, I put -3,
And then I close those big parentheses. Remember your order of operations.
what are you going to do first?
Okay.
Right, inside here, right? What is 4 plus -3?
I heard negative, I heard 1.
1. Because this is the same as 4 minus 3. And then 5 times 1? Heck, no. This one. We got some fractions, that's okay. So 6, instead of x, I put 1/3. Minus 1/3 times, instead of y, I put -9. Well, we got fraction multiplication here, so I'm going to make this over 1. Going to make this over 1, and then I'm going to
Multiply those, simplify them, and subtract.
What is 6/1?
Times 1/3.
6/3, which is 2. So the whole thing
Simplifies to 2.
minus 1 times -9/3 times what? -9/3. And what is -9 divide 3? -3. So I got two negatives, right? Because I got minus, and then this answer is negative. So I got negative, which changes to 2 plus 3.
Which is 5. Don't let the fractions throw you. Okay?
Okay. First of all, you can cross out the
Or not. Because we didn't do negative exponents. So let's do a couple that have exponents in.
So y squared. So instead of y, I replace it with, and this is why parentheses are important.
What is this? Yeah. Is it 4? Is it -4?
4. -4.
Oh, we're having some. Okay, Eva, you seem pretty intense that it's 4.
Why? Why? Yes, you do. Don't ignore everybody around you. You were very assertive saying, oh, it's 4. What are you, crazy? Why do you think it's 4?
Oh my God. Don't succumb to peer pressure, Ava. Yep.
It's 4 because 2, it's in brackets, and 2, there's 2 in brackets equals.
It's, remember, this means
-2 times -2, which is 4.
I told you.
Okay, this next one, instead of x, I write 3. Instead of y, I write -2 again, and then squared.
Whoa. What do we do here? What do we do here? Well, I got two choices.
I could multiply these two and then square it. Or is that the right order?
Romy.
You do the exponents first.
I have to do this first. So what is -2
In parentheses, squared. It's 4.
and then 3 times 4? 12. Just count that.
I want you to do the next one.
Well, first of all, it should look like this. Who's got an answer? Grace?
2, and then in brackets 2, and then which would be 8.
What's 3 to the third?
Oh, 27.
You? And then 2 times 27? Right. Good.
Okay. Watch out for those ones. And then finally,
Well, instead of x, I put 3. Minus, instead of y, I put -2. Square. Positive 5 inside. And I still have to square it. 25.
okay? So that's the first thing we're going to learn is how to actually evaluate these things, which we've done. What we're basically going to spend the rest of the unit on is what if I gave you this? Don't write this down. I told you, okay, x is -7 and y is 2.
I want you to evaluate 2x minus 2 times x minus y plus y squared minus 5y squared plus 6x squared minus 6x squared plus 7, 2x minus 5y plus 10x minus 7y plus 3 plus 2x squared minus 3y squared. Let's see, plus 9x minus
Ring explodes.
4x plus y minus x. Okay, I guess we'll stop there. Okay? Well, there isn't. You have to plug it all in and then calculate.
That, like that.
So this, you're looking at this going, like, is he insane or what? Okay? Well, yeah. You could, every time you see an x, plug in -7. Every time you see a y, plug in 2. And then do a whole bunch of calculating. Okay? But that's not efficient. Mathematicians are lazy. They look for the simplest way to do things. Okay? We're going to learn how we can actually simplify this to make it a much smaller expression. Okay? Just as one example, what do you think happens to these two? Yeah, don't they like 6x squared minus 6x squared? Doesn't that cancel out?
Yeah.
So that's a way to simplify. That's a couple less calculations. Okay? There's other simplifying we can do. Okay, I know, I couldn't even say simplifying. I'm so excited. Okay.
Anyway, that's what we're going to get to in the rest of the unit.